Perfect. Nothing that a little bead blast can't take care of. What's up, guys? Sean here from SBSolo, and we're going to do another episode of how we do it. And I'm going to show you how I actually deburr my parts on and off the machine. So I'm going to go through a few of my favorites, my favorite manual hand tools, and then my favorite cutting tools that I use to deburr parts, and give you a few demos. So yeah, let's just start off with the tried and true file. Right there, a little Mill Smooth file. I use like a Mill Smooth because it's smooth and it leaves a really good finish when I'm filing. I use it for prepping. I'll use it for prototype parts or stuff that I just don't want to deburr on the machine. I'm just really trying to do a hurry. I also use a needle file. Flat on one side, half moon shaped on the other. I actually buff the top of the needle off, little pointy edge, so that way it doesn't poke into my part if I mislip or something like that. But I use this for the little corners or stuff that has to look really nice. This leaves a really good finish. It's a really nice file, but both of these two files are probably my staples as far as files go. All right, so what I have next are my countersink tools. I have these in different sizes. See that? Different sizes. This one's in a shaft. I can put it in a drill gun, and then I can just hit deburr holes and whatever I need to do. I've also ground down the shank a little bit so I can get right into a counter bore or something. Just a bunch of different ones I've had over time to where I can use it. I also have a couple that I've welded like a long little hand thimble on there, and then I welded a set screw on the back of like a little one because I had something I had to get in there, and then kick the Allen key at a side and kind of spin it to try and deburr the part. Different things like that. But when I'm in a hurry, I use my countersink tool. All right, now we have my back deburr tool that we have, a little hand back deburr. You push the little, stick it through the hole and push the button and it flips. And that way you can get in there and do back chamfer some holes. And they're not super strong, but they'll work in a pinch. I've used them mostly in aluminum. I try not to use them in steel because they get burned up pretty fast. It's good to have around, for when you have to do a back deburr hole every once in, 5 years. So it's worth it to just keep around, I suppose. All right, next I have the pizza cutters. You guys ever seen pizza cutters? So it's a little round carbide disc on a shaft. So the cool thing about pizza cutters is you can stick them at an angle and spin it and still deburr your hole versus having to be totally perpendicular to your hole. There's a bunch of different sizes of these, small all the way to big. They are a tad delicate as well, so using them on steel, you got to be careful with them. I usually put them in a drill gun and just go really slow with it, or I can use my hand. Aluminum, you can use your hand, but pretty handy tool to be able to get sideways and try and get in there and spin. Yeah, pizza cutter. It's good to have in your box. So the last two tools that I have on my hand deburr list are these two little beasties. These two tools can be your best friend or your worst nightmare. So this little deburr knife is kind of like a Hattori Hanzo sword, super sharp, and it'll take your life. And this little guy, whirlybird, ring around tool, deburr whip, palm slicer, whatever you want to call it, it's a great tool, but it'll take your life as well. So I'm going to show you real quick how I use these, but just be careful because they'll get you. Ooh. Oh, gosh. Oh, you got me. And that, my friends, is how I use those two tools successfully. Well, we made it through all the manual hand tools, so now I think I'm ready to get into the carbide stuff that I use on the mill. Before I do that, though, I need to change my shirt. Got a little out of hand there, so just a second. That should work. New shirt goofing. All right, on to the carbide tools. First up is the tried and true Chamfer Mill, probably the king of deburring. So the Chamfer Mill probably gets the most use out of all my deburring tools, just because most 2D prints or whatever have chamfer callouts or edge breaks. So you can also use it to spot holes, 45s. You can get different angles of chamfer mills, and just do what your print calls out for. 10 thou, 5 thou, 100 thou. It doesn't matter. You can chamfer an edge with it. So sometimes I'll use a 4-flute, which I'm testing out on my lathe right now, mainly because I have half the spindle speed on my driven tools, and I just need to try and speed that up. So I've been playing around with the 4-flute. It seems to be working, but I just can't use the very, very tip. The other two flutes don't go all the way to the center. So then you're going to have a difference between the upper portion and then the point on your surface footage. And then if you have both of them intersecting, you're going to have one portion that looks really good and the other portion is going to look chunky. So I just tend to just use 2 flutes, plus the chip evacuation when I'm plunging into stuff. Just works really well. So I just stick with the 2 flutes. So that is the Chamfer Mill, a staple of deburring in a CNC machine. All right, so now we have the Ballin Mill, which is a close second to my Chamfer Mill as far as being used. So what a Chamfer Mill can't do, the Ballin Mill comes in and shines. So the Ballin Mill, you have a lot of diversity. You can do anything that a Chamfer Mill can do. It's going to take a little longer, but when you have those, I would say, chamfers that go up 3D surfaces and they need to be perfectly chamfered just like the model, you can surface it back and forth to where, you know, you use a flow line and you're just using that in a way that creates the chamfer in a few different passes versus one swoop with the chamfer mill. So you just have to use a Ballin Mill when those things come into play. So the other good thing about a Ballin Mill is you can do really steep walls with a Ballin Mill. You know, come up real high and go down low, where the chamfer mill you can't do that because you only have the flutes that cut and the shank won't cut, whereas a Ballin Mill, you got that whole radius that cuts. So another good way to use Ballin Mill is if you're just tracing one pass. So you can do like a Deburr tool in a lot of CAD softwares now, to where they make it very, very easy to where you just push a button and it detects all the sharp edges, and you just Ballin Mill and just comes in and swoops all those sharp edges as one pass, and it basically hits it right in the median. I mean, there's no real reason why you shouldn't just be able to click a couple buttons on your software and be able to at least deburr, I don't know, 50% of your part at least, you know, and then maybe you deburr the rest with your hand tools. So that is the scoop on a Ballin Mill. It's your best friend when you have steep angles and sharp edges, surface fillets or surface chamfers on your parts, you know, especially 3D stuff. So yeah. All right, so next up I have the double angle back chamfer mill. So you can chamfer on both sides, the back and the front. So they come in a variety of different styles and shank sizes, diameter sizes. Some of them, they don't even have the front cutting. They only have the back cutting, so it'll be cut flat like a dovetail. So in a certain situation, I use this to deburr O-ring grooves inside of internal bores. And you can stick it in there, and then you can just, you know, hit both edges at one time. So another situation I use this tool for is I had to hold on to a part that had very minimal engagement on the soft jaw. And on Op.2, if I was to cut the chamfer around it, it would basically blow into the soft jaw. And I did do that actually, and my soft jaw started blowing out because it just wasn't enough structure to hold the form of the soft jaw. And I ended up having to recut my soft jaws. So what I did is actually took this tool in Op.1 and I came down and I profiled the outside of the part down at the bottom. So when I flipped it to Op.2 and decked it off, the chamfer was already there and I didn't have to cut into my soft jaws and ruin the soft jaws and the integrity of the soft jaw. This is probably a good situation where I probably should use steel soft jaws just because I'm just grabbing onto such a little portion and the aluminum likes to deform, but this allowed me not to have to do that or make fixturing, you know, for Op.2. Whereas I could just use the soft jaw and it works just fine. So that is the double angled back chamfer tool. All right, so this is my favorite deburring tool out of all of them. It's like an MVP sometimes. Sometimes it doesn't get used, but when you do use it, you realize like, oh man, this tool can do a lot of stuff. And so that is the Lollipop Mill. So with the Lollipop Mill, I use it quite a bit for deburring backsides of holes. I have a really small one that I can get in and cut through pockets. You can actually get an undercut and deburr all your edges, which can come in so handy when you're on a 3-axis machine. I use a Lollipop Mill to get in there so I don't have to hand deburr anything. And there's also many different styles of Lollipop Mills. You have the engagement of the Lollipop itself, which can be like 220 degrees, 270 degrees, 300 degrees. And the difference is you can use that many degrees of the flute. It's just the shank's gonna get bigger or smaller. So you have to kind of dictate what do you want. You want strength, or do you really need that full radius? And then you sacrifice rigidity and strength, but then you can actually hit a little bit farther on the Lollipop. When you start getting the 4th or 5-axis, this is gonna be your best friend as far as deburring goes. I used to do these a lot on my 5-axis machine when I was working at an aerospace company. And man, there's some, like you can only tip so far. Like I think we had 125 degrees tip, but it wasn't enough to hit every feature. So you have to use a Lollipop Mill to get underneath, and you can just break the edge, and so you have a complete part that is completely deburred versus, you know, having a 3-axis or a 4-axis that you just can't hit it. Even with the Lollipop, you just can't hit certain features. So yeah, when you start getting into 5-axis stuff, you're going to probably enjoy having these little guys. But that is the Lollipop Mill, and it is one of my favorite tools to use as far as deburring goes. All right, for my last tool, I'm gonna throw in this corner round tool. It's not necessarily a tool I would use to chamfer or deburr parts with. It's just more of a tool that I would use to actually put a feature on a part. But if I already have the tool in the machine and I have to do a feature, let's say like a 20th thou corner radius called out, and it has to be specific, I'll use that same tool, maybe back it off a little and break some different edges if it's in there, and I don't want to pull up like a chamfer mill if I'm not using one. So yeah, I figured I'd mention it. Obviously there's tons of different sizes of quarter rounders. You can get them any size you want. You can have them custom made. So that can be a nice little tool to break some edges if that's what the look you're going for. So there you go. That is a corner round tool, and that concludes my deburr arsenal for machining and not machining. So before I go, I did want to mention like when I use my tools in the machine and when I use my hand tools. Realistically, for me, I do a lot of production, so I want to do that 100%. I want to do all the machining and all the burring in the machine 100%. And I don't want to scratch parts or just have that risk of just having the parts look irregular. I just want them to look crisp and clean. That way they're all the same and you don't have any manual error doing that. If I was doing prototype work though, and I didn't have an easy way to deburr and I just going to take a lot more time to program, I would just pull that part off and basically just hand deburr it. But if the prototype was actually going to be an example for a company that was probably going to go to production, and a good feeling is going to go to production, I probably would deburr the whole part. That way they could see what it's going to look like off the machine and like production line wise. So they get a good representation to qualify what the part's going to be. Now I've worked at companies that, basically the operators load machines and they have enough time to deburr at their bench. I've also been in places where they don't even deburr at all on the machine and the operator doesn't even deburr, but a whole different department deburrs the parts. And I think to be able to do that successfully, one, you have to have the right type of work. And a lot of aerospace work, you're actually allowed a deviation to use hand tools and buffing and grinding stuff to get the profiles in shape and the form, because most of the time they're getting painted. So I think it's super dynamic though. You can, it's just the time of the day and what I'm running and whatever, I'll end up, deburring by hand or just deburr on the machine. So yeah, that is the conclusion of my deburr tools and how I deburr parts. All right, I just want to say thanks for watching this episode of How We Do It on Practice Machinist series. If you haven't seen my other 2 episodes prior to this, you can hit the series button and then drop down and it says How We Do It. You can watch those if you'd like. If not, you can catch me on SBSolo Co. on Instagram. I'm on Instagram quite a bit. But yeah, if that sounds something you're interested in, cool. If not, cool. Other than that, I will catch you guys on the next one. I have a lot of other ideas to make more episodes, and I think you guys will like it. Later.